Chapter 10, Lesson 1. Graph y equals ax squared plus c. So what we're going to be dealing with today is we're going to be dealing with this idea of how to graph what are called parabolas. And a parabola is basically sort of a U-shaped figure that we're going to go ahead and deal with and become pretty familiar with pretty soon. So the thing to understand is that a quadratic function is a function that can be written in the form of this. Y equals ax squared plus bx plus c. Now this should seem pretty familiar because we've been already solving for roots when you have an equation that's ax squared plus bx plus c. We've already been working with this a bit. So every quadratic function is a U-shaped graph called a parabola. The most basic one in the family of quadratic functions is y equals x squared. And we're going to get to how that looks in a little bit. The line that passes through the vertex and divides the parabola into two symmetrical parts is called the axis of symmetry. What that means is, again, if you have here something like that, I know it's not perfectly drawn, the line that goes down there, and if it were to fold over, that would provide symmetry for that shape. And so that's the axis of symmetry. The lowest point, which should be down here, lowest point is called the vertex of the parabola. So, for example, the vertex of the parabola for 0, 0 is going to be equal to, or for y equals x squared is going to be 0, 0. And we're going to just experiment with this and do a bunch of graphing now. So let's get rolling. Graph y equals ax squared when a is greater than 1. Okay, so it says here y is equal to 2/5 x squared. So you start first of all by making a table of values. And I always personally like to start off with the 0, 0 part here and then branch out from there. I realize I'm going to do 0, 0, and then I start going on either side. So if I plug in 0 into that equation, it's going to be y is equal to 2/5 times 0. So it's just going to be 0, 0. If I do y is equal to 2/5, and that's 0 squared, sorry, is equal to 2/5, then it's 5 squared. Then that's going to be equal to 5 squared is 25. 25 times 2, 50, divided by 5. So y is then going to be equal to 10. So my point is going to be 5, 10. And so that's how I end up with this. And you just plug in these values, and when you plug them in, you'll see that you end up getting there. One thing that's really key to understanding is you've got this, is if you plug in the negative 5, I want you to see that. So it's going to be y equals 2/5 times negative 5 squared. Okay, that still is going to be equal to, negative 5 squared is 25, because negative times negative is positive. 25 times 2 is 50, divided by 5. It's just divided by 5, not by negative 5. Divided by 5 is going to give you 10. So negative 5, 10 is going to be another point here. And same thing, you'll notice that there's some values that match up here. The vertex in this case is going to be 0, 0. That's going to be the lowest point, the trough, or the lowest point in the actual graph. And the axis of symmetry is x is equal to 0, because that's where it kind of flips over. And if you were to notice, we're going to deal with a couple of other graphs now. So let's see here. So this here is y is equal to 2/5 x squared. And then this one here is equal to y is equal to x squared. So one of the things you may notice here is that the value here might look the same, but they're not. Because the value here with the y equals x squared, it goes up a lot faster than the y is equal to 2/5 x squared. They look similar, but this one here it's not, the x squared value is not taken a fifth of and multiplied by 2, which is what is happening here. So it ends up being the y value goes up significantly less quickly in this one here than it does in the other one there. So graph the function, compare the graph with y equals x squared. So y equals x squared is, again, this constant thing we're going to come back to. But here, check it out. It's going to actually go up even faster. So we're going to go ahead and plug in, let's just do a quick table of values here. Okay, so I like to actually write this out like this. So I have, let's see here, first of all I have x, then I have 2x squared, then I have what the value of y is, and then my points, x, y. That's how I like to write it out. Make sure it's a little bit clearer. So when x is equal to 0, I'm actually going to put this one here. When x is equal to 0 for this, y, this is going to be 2 times 0 squared. And so y is just going to be equal to 0, so it's going to be 0, 0. Now, when x is equal to -1, it's going to be 2 times -1 squared. -1 squared is 1 times 2, so y's value is going to be 2. So that's going to be -1, 2. Then I like to go over on the other side and see what happens with the 1 value here. It's going to be the same thing, 1 squared, 2, so it's going to be 1, 2. And then we're going to go ahead and graph at least one more set of points here. So let's see here. Let's say x is equal to -2. -2 times -2 is going to be 4. And then times 2, that's going to be 8. So -2 times -2 is 4, times 2 is going to be 8. So my point is going to be -2, 8. And for this one here, it's going to be, if I have 2, it's going to be the same thing, 2 and 2 squared. So it's going to be 8, so it's going to be 2, 8. And when you graph it, you'll see that there's a nice U shape to it. For this one here, easiest way of thinking about it here, this one here is going to look different because the y value goes up less quickly. So it's going to be kind of a spread out version of this. So let's look and see here. If we were to go ahead and do this, I'm going to just come up with the table of values and show you what I mean. Okay, so what I did was I went ahead and I graphed this all, made it nice and colorful so that the red point matches up with the red point, the green point with the green point, the blue point with the blue point, and the orange point with the orange point, and the black point with the black point. So if you look there, if then we graph this whole thing, what it's going to look like is it's going to look like this. Or at least approximately like that. It's hard to actually draw it perfectly, but so that's how it would look if you connect all the dots. And again, you have this nice sort of U shape. So when this here is happening, the only thing that changes is the direction. You're going to be you're going to be facing down because everything is going to be a negative value for y when you have a positive value or when you have either a positive or a negative value for x. So it's going to end up looking something like this. I'm not going to actually calculate it, but it's going to look like that instead. That's what that negative value does. This one here, it's going to be wider than the regular one, but it's going to be pointing down again. So for this one here, it says here graph a x squared plus c, and for this one here, the important thing is that everything here, you can just graph this part, but everything is shifted down once. So your vertex is going to start right here instead. And then it's going to be pointing up. It's going to go up pretty quickly. But it starts at -1 instead. That's what that value is there for the trough point there. And for this one here, you can visualize it's going to start at -2. It's going to go kind of up like this. So basically, those are the key concepts associated with graphing y equals ax squared plus b. We'll cover more of this in class.